We have a male connector that we put on the end of that cable. It's got 8 pins that's going to line up with those 8 wires. Nothing too exciting here. And what do we do at that end? We plug it into the female end. So the wall jacks. The network interface card. But there's something more important, Dan, that we really have to understand about our unshielded twisted pair cabling and our shielded twisted pair cabling. And that is how we take those wires and put them inside that connector. Because it's going to determine how the actual electrical signals are being transmitted through that cable.
This is something that is a really big deal for 10 meg Ethernet, 100 meg Ethernet, when we are using UTP. So let's revisit something. How many wires do we have inside of one of these cables? We know we have 8 wires. 8 wires. And some of the early standards didn't use all 8 wires. That's fine. No problem. But there's 2 types of UTP cabling for every category of cable out there. I could have straight through Cat5 UTP, but I could in fact have a different kind that is pinned out radically differently. That's called a crossover cable, so I could have the exact same rating of cable, same type of cable, but it could be pinned out differently. That means it has a different layer 1 specification. And if we use the wrong cable type in the wrong scenario, our gear won't have any physical connection between them that can be used. Might have a cable, but our network interface cards wouldn't see it properly. So, Raymond, how should I think about these 8 wires? I've got to transmit and receive somehow, some way on those 8 wires.
When we're thinking about straight through, you have to be thinking about one pin at one end going straight through to the other pin at the other end of that wire. That's why it's called straight through. There's nothing crazy about this. 1 goes to 1, 2 goes to 2, 3 goes to 3. Really easy to remember that. But Dan, when we get to crossover, things radically change for us there.
Let's take a step back for a moment. Think about when you're talking into your cell phone. There's 2 audio interfaces on a cell phone. There's the speaker and then there's the microphone. Now, Raymond, when I communicate, when I'm speaking, that's going to go into the microphone end of my cell phone. But if we were to follow those audio signals that are converted into a digital waveform, a digital signal representing a waveform, where is that ultimately going to wind up? I'm thinking about my audio going into the microphone. Where does that wind up if I'm talking to you, if I'm calling you on your cell phone?
It's going to come out the speaker on my cell phone. So it's gone from your microphone to my speaker. And then when I respond back to you, it goes from my microphone back to your speaker.
So there's sort of a crisscross action going on anytime we are performing communication. Our side that is transmitted goes over to the area where they're going to be listening to us. And any communication whatsoever has to follow this rule, which we call a cross. We call it a cross. And this is the cause and the trigger this need of performing a cross is the reason why we have a crossover cable. So and in fact, one of the ways that Raymond began our discussion a while ago, not really recently, but a while ago, he was talking about what happens if we cable two computers together directly. Is that a LAN? The answer was yes, it's a LAN. It's not a very big LAN. And in fact, those devices are both endpoints and weren't really expecting to talk directly with each other. So the proper cable to use there would in fact be a crossover cable. Now Raymond went through and discussed the pins 1, 2, 3, 6. We still use 1, 2, 3, 6. But Raymond, I don't see that straight through action anymore when we're looking at the communication flow that would happen in a crossover cable.
Well, Dan, if we think about that PC to PC scenario, if we used that straight through cable, notice pin 1 would go to pin 1. That would be transmit to transmit. Pin 2 would go to pin 2, transmit to transmit. That would be the same thing as taking my cell phone, turning it upside down, so that way there when Dan talks to me, well, now I'm speaking into the speaker and I'm listening on the mic. That doesn't make sense. That's not going to work. So we have this crisscross happening. That's what this crossover cable is doing for us in that PC to PC scenario. Notice, pin 1 goes to pin 3. Transmit to receive. Pin 2 to pin 6. Transmit to receive. Pin 3 to pin 1. Pin 6 to pin 2. So we're doing this cross to make sure that the sending device is sending on the transmit pins and the receiving device is actually receiving on the receive pins. Now it's important we remember this pinout here. And Dan, is there an easy way for us to remember this pinout?
There is. There's this thing called the rule of 3. Now, if you're a survival expert, the rule of 3 means something very different. You can survive 3 minutes without oxygen, 3 days without water, 3 weeks without food. But in this case, the rule of 3 is going to help us remember that pin 1 goes to pin 3. Pin 2 goes to pin 6. So just multiply by 3 and you'll never go wrong. And you, in some environments, could be expected to remember the precise pinout of a crossover cable.
So you're saying, Dan, that I can take 1 multiplied by 3 and I get my answer of 3. So 1 goes to 3 and 2 times 3 is 6. This is great. That's one of the easiest calculations I've ever had to do.
We still have to think to ourselves, however, when do I use each of these cables? We haven't really thoroughly discussed that. There's a time and a place for a straight through. There's a time and a place for a crossover cable. And to be successful in the real world, we do need to know this. If you're thinking out there, well, I know I've got some auto-sensing functionality in my Ethernet gear that is going to solve this conundrum for me. So I can always use a straight-through cable. That's mostly true. That's mostly true. However, not all gear supports the auto-sensing where you could use a straight-through cable for everything and internally the NICs that are part of your infrastructure will perform the cross dynamically, so to speak. Not all gear supports that, so it's safer to know this behavior. So straight through crossover. So first off, Raymond, if you're talking about a normal patch cable, normal Ethernet cable, which would be the norm?
The normal would be a straight through cable. connecting our PCs to switches, connecting our switches to routers, we would use straight-through cables there.
Let's give you some rules. And these rules are really good to remember. Use a crossover cable whenever you are cabling like devices together. Like devices, as in similar devices. So, anytime you're cabling the exact same gear, a switch to a switch, a router to a router, a PC to a PC, or a PC to a server, because PCs and servers just have different internal operating system responsibilities, that would demand a crossover cable. However, Raymond, when I look at the top row, I'm a little confused by this. If I just follow this like devices. And I'm also confused by an icon that we don't see all that much in this course. What's the icon that has just the single arrow in the top row here?
That would be a hub, Dan. Definitely we don't see those today.
Raymond, now going back to the rule, like devices should use crossover cable. I know that switches and hubs are fundamentally different. Hubs work at layer 1 of the OSI model. Switches work at layer 2 of the OSI model. So that rule seems to fall short. What is a good way to generalize what it means to be like devices? In what regards is that?
Let's think back to our physical topologies. Specifically, the star topology. What did we see? We saw a central device in the middle, which was our hub. Not a physical hub, but it could be a switch. And then around that, we had all of our spokes connected in. Anything that we could put in the middle of that hub and spoke topology would be a like device. They would be similar in nature. Anything that we could put around in our spokes, they would be similar to each other as well. They would be like devices.
Now, you may not recall this, but a while back, Raymond was talking about a hub and spoke topology and what would exist in an Ethernet hub and spoke topology. And he mentioned we might have PCs. But he did mention that the spokes would also be routers. And it's because routers terminate broadcast domains too. They don't build larger broadcast domains. They don't function as the hub of the hub and spoke topology of an Ethernet domain. So in this regard, this would justify the PC to the router scenario because they both exist as spokes in the hub and spoke topology. So think about it that way. And you'll really never go wrong because we're teaching you the down and deep mechanisms, and then we're showing you when to use what. So there might be some surprises with the straight-through cables as well. Switch to router, normal. You definitely expect to have straight-through there as well as switch to PC. Then we look at the others here. It's just more of the same, isn't it? It's more of the same. Now that we understand that hubs and switches, in regards to this wiring issue, they're the same, and PCs and servers, and even routers are the same, we go, okay, no surprises there. That's what I would expect. And ultimately, the reason why some of this works is if you look at behind the scenes, if you look really deep, if you want to look at the crosses here, there's a certain number of crosses that should exist between any two connected devices. And it's 1 or 3. You need an odd number of crosses in order to satisfy the requirements. Just think about it. Transmit to receive. That happens once. But if you bounced it 2 more times, transmit to receive, to transmit to receive, well, you know what? That got it. It's circuitous, but it got it. So there might be some scenarios where we're going to have 3 crosses. That's what we see in the switch-to-switch and what's equivalent to that, because internally on switches and hubs, the interfaces themselves perform across in addition to the crossover cable, which performs across. So we might get 3. That's not a problem. We need an odd number of crosses, and we can see now we've got our network cabled up properly if we followed these rules.
Dan, you made a very valid point there about the functionality of our switches. You said they perform an internal cross themselves. And that is why the straight-through cable would work between the PC and the switch, or the switch and the router. Because our PC is transmitting on the transmit pin, we use the straight-through cable, but once it arrives at the switch does the cross, and it comes in on the receive pin. That's why straight-through works there. And why we need the crossover cable when we have switch-to-switch. Because if we're both doing a cross, like Dan said, and we throw another cross in there, we're back to being transmit-to-transmit. So keep that in mind, that our devices are designed to function a certain way to give us the connectivity. We have to use the right cable to make things work. Where are we going to utilize fiber in our local area networks? Are we going to use fiber to the desktops? It would be nice, but it's not necessary. We are going to use UTP cabling to the desktops. But one place where we might use fiber is for our switch-to-switch connections, our uplinks. That way there we can support the higher bandwidth that is needed as we aggregate our links from the access layer up through the distribution layer. So it's good to have an understanding of what makes up a fiber optic cable. So what do we see here, Dan? I see really 3 different components here that make up our cable.
Well, we've got the buffer, coating, stuff on the outside, and then we've got cladding. The way that I think about the cladding is I start to think about the fact that we want things to keep on reflecting inside of the fiber optic core. The core is where the photons are going to be traveling, and the core is normally glass or plastic, something that is transparent to the wavelengths of light that we're sending down the fiber optic medium.
There are 2 different fiber optic media that we can implement depending on what our overall goal is. We have multi-mode fiber and we have single-mode fiber. Now, when might we use each one? We'd use multi-mode fiber for shorter distances, for our uplinks between our switches. But Dan, we'd use single-mode fiber when we have to go over longer distances, when we're running kilometers or miles of cable, and we have to go great distances.
And the industry vastly prefers single-mode fiber. Here's the physical difference between these 2 media. Multimode can support multiple lambdas. A lambda is a wavelength. And you can see that here illustrated with the jagged lines bouncing around off the cladding, traversing the core from one side to another. And supporting multiple modes, which is different wavelengths, is detrimental to the integrity of our signal the longer we go. So when we squeeze the core smaller, and we negate the possibility of other lambdas, as single-mode fiber does, we can naturally go further. So it's a little counterintuitive if we think, I want more. But in this case, we want less. We want a single mode being transmitted on our fiber optic media.
Everybody take a deep breath right now. I'm looking at all these different types of connectors for fiber. We talked about unshielded twisted pair cable, and what did we see? One connector. And now we get the fiber connectors, and we see 7. And that's all that we have here, but it's not just 7. It's 50 plus different types of connectors that are available out there. Dan, do we have to memorize all the different types of connectors?
I wouldn't want you to. But the ones that you're most likely to see, I would say, are the ST, the SC, the FC, and the LC. Those are the ones that you'd expect. And thankfully, because there are so many, we generally don't get caught up in the memorization of this. And inside of your environment, you may have one of these as your predominant connections, and you'll get used to going, oh, that's an LC connection. That's a ST connection, and you'll just simply get used to it. We do need to be considerate of the fact that these are not as, or let's reverse it, these are more fragile than UTP cables. So they're delicate, treat them as such. It's not like we have to, touch them lightly, but you certainly don't want to crimp them. And the termination of these is quite a bit harder than the termination of the RJ45 jack.